Imagine it's Monday morning. You just logged in using your MFA authentication. Now you just got yourself a nice cup of coffee, sipping your coffee. Do you feel secure? Because you just logged in via MFA. Or is there already Cookie Monster lurking in your browsers and watching for your cookies? Welcome to today's session. I'm in your browser, eating your cookies and bypassing your MFA. Before we start, I want to thank our amazing sponsors. Thank you so much. I'm Miriam, and I currently work at Microsoft as a security research PM. Technical program management, and my focus area is now Sentinel research. You can also find me on GitHub, and I will also put up my presentation and relevant stuff after the conference there. And I also authored the book PowerShell Automation and Scripting for Cybersecurity, Hacking and Defense for Red and Blue Teamers. Who of you was here at PowerShell Conference in 2024? Who of you attended my session in 2024? So some of you might remember it, not all, and this is why I'm quickly explaining what happened before. So basically last year, I did a session on a real-world attack where attackers are abusing Microsoft Graph APIs to actually extract information and extract emails, starting with a password spraying attack. Back then, when the original attack, there was no MFA present. But thanks to some Microsoft efforts in security, I was not allowed to disable MFA in my test tenant. And so I ran the demo, everything worked fine, and at some point, MFA popped up. And I had to say, oh, yeah, well, originally MFA was not present in this scenario, and now I just have to bypass it by just entering the code and say, okay, you're authenticated. This led to some comments after the presentation where people asked me, hey, how are attackers actually bypassing MFA? I would be really interested to see such an attack. And this is what led to this session. How are attackers actually bypassing MFA? So there are a lot of options, and probably more than I'm listing here. And today, I'm showing how attackers are bypassing MFA authentication by using cookie replay. And who likes cookies? Yes, everybody likes cookies, but there's one person, figure especially, and it's the Cookie Monster. So let's say the Cookie Monster is looking how to get more cookies, and love that shirt, sir. And the Cookie Monster wants to get more cookies in order to bypass MFA. And so what the Cookie Monster does in our attack scenario, the Cookie Monster sends a prepared email with a link that if Miriam, the user, clicks the link, a script opens and extracts the cookies. And every browser does have a database in which cookies are stored. And in our scenario, Firefox does have the cookies SQLite database. And after the script started, the Cookie Monster extracts the database and copies it to its own computer and machine. as a next step, the cookie monster extracts the cookies and replace the cookies in a headless browser. A headless browser, for those who don't know what a headless browser is, I assume you know, but for those who don't know, a headless browser is basically a browser that you can just control via script. You don't need to open the browser window, but you can just run your script and do everything as you would do it in a usual browser. Then we can reuse the cookies for device authentication. And in our demo, I will later show you why we have this step here and why we just can't use the token. And then the cookie monster bypassed MFA authentication can run Azure PowerShell and extract all the data that the cookie monster wants to. Let's look how that works in a demo. So as module requirements to make this demo work, I use Selenium to automate the headless browser part, and I use the SQLite module to also access and interact with SQLite database. Yes, of course, I'm sorry. Is it better, or do you need a little bit more zoomed in? One step more, like this? All right. So first we have some functions here. So first we look if Firefox is installed. We extract the path from the file system where the cookie SQLite database is located. And we have a function that actually gets the path and then queries the cookies from the database. And usually you have cookies set for a certain URL. And when we are looking for Azure device authentication, for Azure authentication cookies, the path is login.microsoftonline.com. So we run our commands and we have all cookies now here in the cookies variable. As a next step, we actually want to set the cookies and replay the cookies in the browser. And for that, we have the function setCookies. So for that, I use Selenium to actually start Firefox as a headless browser. I go to the URL login.microsoftonline.com. Did that work? Let me just run it once more. And then you can see that all cookies that are actually present are the following ones that you can see here below in the terminal. And that the ESTS auth persistent cookie was not set yet. The ESTS auth persistent cookie is the cookie responsible for the persistent session. So if you say, I want to stay logged in for Azure, then this cookie is set in the background. And this allows you to authenticate just without logging in again for a certain amount of time. Now we are setting the cookies, we are replaying the cookies. Basically, there is a new cookie set for every value that we extracted earlier. And you see all the cookies that are being set, the cookie name and the value. And here you see the ESTS auth persistent cookie is set as well. And after this command completes, we can now look and check if the cookies were actually set. And you see there are way more cookies now set, and also the ESTS auth persistent cookie. And with that, the cookie monster has already extracted and shared all cookies. And who wants to have a cookie? Now you need to be very good with catching. Oh, I don't know if I can make that. I try. Oh, no, sorry. And if I'm not good enough with throwing, you can also try to pass some to the back. And oh, I'm sorry. And basically, I also wanted to ask who wants a cookie, because you get a cookie, and you. Oh, sorry. Okay, throw them one by one. And there are also some cookies left in here. So if you want a cookie after the session, there are 8 left in here. So please get yourself a cookie after the session. So let's go to portalazure.com. I did not think that I would be as sporty as this in the session. I told you earlier that we are going to look in the session why we also need to have a device authentication. So if you have an access token present, then, and I'll run it before I explain it, because that takes some time. If you have an access token, you can authenticate with an access token. And usually you have those tokens in the browser cache. So you have local storage or you have session storage. And here we are querying the session storage where those JOT tokens are located. Basically, an access token helps you to access a resource, while a refresh token helps you to get more access tokens. So if you have the refresh token, you can get yourself as many access tokens as you like to. Access tokens usually have a duration of 1 hour after they expire, and therefore, if you have the refresh token, you can get more access tokens. There's also an ID token, which just means, okay, you are the user that you authenticated for. So ID token, authentication, access token, authorization, and refresh token get more access tokens. And basically those access tokens are the magic also behind querying more data. And now we completed our command. So you see we have here a refresh token, 2 access tokens, and 1 ID token. We have a JOT token present. And if we now say, okay, we just want to have one of those access tokens, we want to have the access token extracted, the JOT token from the access token, where organization read all is in the target property. Then we have now here everything in the access token. Now let's try and reuse the token. For that, I have the invoke graph web request function, which just invokes a graph request over Azure PowerShell. And we try to get all the UPNs of Peanut record users. And, I'm sorry. For that, we just invoke the graph request and try to get the response. But you see that the access token validation failed because the scope was not the right scope. So let's look a little bit further at the access token. And we do have the .ms webpage where we can analyze the access token, the JOT token. And I just pasted here the access token that I extracted earlier. And now you see here is the app ID. Although user, UPN and stuff are correct, you have the app ID here that restricts your token. Now let's go back to the presentation slide and look a little bit at this token. So here's a summary again: access token, refresh token, ID token. But those tokens can only be used in the scope that they were set to. So if a refresh token was created for the Azure portal, then it can also only get you access tokens for the Azure portal. And the access token can only be used for the portal. And if you remember the ID that you saw before, the C44, this is the ID, the app ID for Azure portal. This is a well-known ID, which is just set like this. So we can't use this to query with Azure PowerShell. What we need is the Azure PowerShell ID present in the access token. And we can't just extract that from the browser. And therefore, we need to do device authentication. So maybe some of you already did device authentication. When you have a device where you don't have a UI present, for example, or in an authentication flow, then you just request device authentication. You get a code that you enter, then you pick an account, either you log in or use an account that whose cookies are already present in the browser. Then you say, yes, I want to sign in, and boom, you are signed in and have completed the device authentication. Going back to the demo. And now we are performing device authentication. We get back an object where I can extract the user code, the device code, and the URI. And I do have a function here, get access token. This takes some time. This is why I'm running it immediately. So with the get access token function, what I'm doing, I'm leveraging Selenium again to go to the verification URL. I find the elements where I need to enter my user code. I enter it, I click it automatically. And then on the next page, so I wait until the next page is loaded. On the next page, I click yes, I'm really that user. I wait until the next page is loaded and I accept and say, yes, I really want to authenticate. Boom, we are authenticated. And now we also have our access token here, which I'm copying now. So for us to analyze. And if we look now to the app ID, you see here 195, it's the app ID of Microsoft Azure PowerShell, and now we can leverage this access token to get access. And now we are going to do the same commands that we did before, and bam, Cookie Monster got not only the cookies, but also access to Azure and can now enumerate all the users, can look for further configuration, vulnerabilities, and escalate its privileges. And with that, we can also now stop Selenium. So what can you actually do to protect your environment? So, yes? No, not in all cases. So it's not that you should block the things that you actually use, because it's with everything there's black and white. And of course, device code also has some right to exist. But also MFA has some right to exist. So I expected actually when I asked this question that people say, oh, don't use MFA. But this is also not the right approach, because in the original demo, I did a password spraying. And that would have succeeded without MFA. And this is way more dangerous. Yes? Yes. Require re-authentication. Also limit the scope of your access tokens and a lot more. So MFA is still important.
Is the access or refresh token bind against the IP, so the attacker must on your device, or is it possible to steal the token and use it on your own PC?
I think it's possible to steal the token and use it on your on another PC. Yes.
It would be easy to check on the Microsoft side if the token is used from the same PC.
Yes, we are coming to that point later. Yes.
So you said the cookie you were using was for the persistent login.
Mm-hmm.
If you don't use persistent login but seamless sign-on, it will also not work?
There would be another way, I'm sure, because attackers are always finding other ways. But yeah, so one option is to also limit persistent sign-on, and also delete your cookies after you log out. So also some other things that you can do is to also enable conditional access. It means you can also say you need to be on a corporate joint device so that the cookie monster just can't extract it on its own PC. Also leverage the other identity protection mechanisms like identity protection policies, logout policies, and everything that is there. So just don't leave it unconfigured. Also, legacy authentication and legacy MFA mechanisms are a big problem. Make sure to assess what you have in use and make sure to block the legacy stuff. And this part is the most difficult part in my opinion, because your users have to comply and basically educate them. Make sure that your users are aware of what they are doing. Delete cookies. Do not allow persistent sessions. And of course, you can also configure it. But your users are similar, like attackers. They are also trying to find ways around everything just to make their stuff work. Make sure to monitor, because of course, attackers, being attackers, always trying to find a way. And if it remains undetected, you are blind what happens in your environment. So for example, if you have an XDR, you can look for risky users. So risky users are, for example, users that raised impossible travel alerts, for example. So if I'm just here in Sweden and in the next hour I'm in San Francisco, well, that does not work, right? So there are also other parameters why a user is considered a risky user, but this is just to explain. And anomalous tokens, or if a stolen session cookie was used. In some cases, you only have a theme, or are building your own detection rules. So look for suspicious sign-in patterns, like we just said. If the location changed, if the internet service provider changed, if an anonymizer is used, for example, or if the user agent is different, that might also be a strong indicator that something is fishy and you should investigate. Also look for strange patterns when it comes to Microsoft Graph or mailbox activities. There are tables there in Azure. And also, last but not least, also look for suspicious PowerShell activities. Look, was there some headless browser activity maybe, or were the cookies or the session or local storage accessed, and maybe something extracted. And of course, you have to start somewhere, and there might be work coming your way. But to make it easier, at least with location or user agents, I wrote this quick starter snippet, so you can also just take this snippet and adjust it to your environment. It's nothing big, it's not rocket science, it's just something that you can run to detect users that successfully authenticated using MFA, but were using this login from different IP addresses or had different user agents. And if one or more IP address was used for this user, or one or more user agent, you will get a hit with this query. And with that, basically, the answer is not to have one single silver bullet for everything. What you should aim for is to build as many layers as possible to secure your environment. Make it complicated. Raise the return of invest for attackers. Make it as hard as possible. And like this, you can manage to defend your organization as well as possible, and to keep the cookie monsters out from stealing your cookies. And with that, we are already at the question part. So are there any questions? Yes.
Detects if you use a different user agent. So if somebody was actually using PowerShell to automate things,
Yes.
Would it also trigger on this because that's a different user agent?
So the question was, if a user would use PowerShell to trigger different things, if it would also show a different user agent. And the answer is yes. But there are circumstances under which the same user agent could be shown, because attackers, being attackers, trying to lure you to believe what they want. And actually, a user agent is nothing that is set in stone. You can also say, hey, the user agent is Mozilla Firefox or Google Chrome with exactly this version string that you set. You can also say the user agent is Pinky Unicorn 1337 or something. It's what you set. So it's just an indicator, but it's nothing set in stone. Yeah. But you should just set it to a time frame that just makes sense for your organization.
The Chrome and the Edge key stores protected or encrypted in any way?
That's an amazing question. So the question was, aren't Edge and Google Chrome cookie stores protected? And the answer is yes, they are encrypted. In this demo, I used Firefox to make it simple and just to show it. But yes, so Google Chrome and Microsoft Edge cookie stores are protected, but it is possible to decrypt them and to nevertheless extract the cookies. So this also adds another layer, of course, but attackers can also circumvent that. And I think also in common tools like Mimikatz or I think also the AD internals, I think they have also a decryption method implemented. Yes.
Have you disabled Microsoft Defender for this demo, or would that catch it if you try to steal from Firefox?
So I did not install Defender for this demo. Yes.
Application to recreate things. If you were to block or severely limit that down to a certain number of accounts, would that provide a broad approach to mitigating this type of scenario?
So that would at least add another layer. So the question was if you would limit device authentication. Again, it always depends on your scenario. So earlier there was a suggestion to block device authentication. And if you don't use device authentication in your environment, that's fine. But in many environments, you still use it. And you just need to tailor it to your specific needs. So yes, that might add another layer of protection. But if you never use device authentication and then the attacker just comes in and uses device authentication for the configured amount, then you still have bad luck. And if you restrict your users or your administrators, they might even get better or even more creative than attackers. So, and they know the environment. So make sure that everything works also for the people that need. Yes?
The script which extracted the cookie database, would the script work if the user was not local admin?
Yes, I was not local admin in my machine.
Is that an option to reduce the validity of the token that's being issued?
Yes, so the question was if an option is to reduce the validity of the token. That's also something that you can do, but again, you don't want to annoy your users if they have to log in again and again, so you need to find the right balance. And if the user is just logged in when the attacker is running the code, then even with an access token, the attacker can just extract the access token, the refresh token, and just replay. So it's always a question of balance.
And using the refresh token, can you reissue another access token on two separate devices?
I have not tried it, but I think so, yes. Yes.
Yeah, for the app ID that's using maybe it's restricted the users and go to that app ID because that's just an application.
Can you repeat the question more loud, please?
Yeah, sure. So the app ID is another enterprise application in the app ID, right? So that,
Yeah.
can be restricted to that if only the certain users can use it, or is it something that can be open to everybody because it looks like it's using the Azure PowerShell or
Yeah. That can be restricted. I can't directly name you the option, but that can be restricted in the app permissions. Yes.
So your method that you showed was based on the fact that the bad party from that actor had to extract a SQLite database from the user.
Yeah.
That would require malicious application on the user's device, But is it possible for a bad actor to have a malicious website ready, put the user on it, and read the entire jar from the browser?
Yes, that's also possible. If you check my code in the demo, the part that did not work. So if you want to have access to Azure, then you can just lure the user to a web page with XSS. And you see here in this part to get the JOT tokens. Oh, yes, you are right. Thank you so much. So yeah, my computer is switching. So you see here, this was the part where I extracted the JOT tokens from the session storage, and this is actually script. So this is just run in the browser in Selenium to get the access tokens extracted from the browser. Of course, this has the scope of Azure Portal, but you can find ways around that. And my approach was to use device authentication to get around that.
So actually there's no protection from reading all the cookies from the jar in the user, right? It's just to use this beautiful website. The attacker will always be able to read all.
I think so, yeah. I'm not a browser expert, so I don't know if some browsers have a restriction against such kinds of attacks where the attacker just lures the user on a malicious web page and reads everything out of the browser using script. But I think currently, yes, that's possible. And the only thing that I would do in this case, or what I would recommend in this case, is to have a protected web access. So we have reputation mechanisms that if you have the what is it called? Is it network protection? I haven't used this feature for some time, but there is also this network protection feature from Microsoft that checks before you enter a web page if the web page is legit or if it runs malicious code, if the reputation is fine. And if the reputation is not fine, then the access will be blocked. And if it's fine, the user can access this web page. Again, layers of security. Yes.
We saw earlier the alert for stolen session.
Yeah.
What are the indicators for that? Is it IP, session talk, browser session, etc., or is it something else that is behind that?
I don't know if I am allowed to answer it, so I would check before I answer. Yes.
So we are currently using the headless browser in this method. Can you mask this method that looks like a normal user when using a browser, or is it like the same effect at the end? You have like mechanisms to check for these attacks.
So it depends what you want to mask. Of course, everything is possible. So you can, for example, mask the user agent. That is an option. But if you use PowerShell to run the headless browser, then of course, if you are smart enough to configure the logs, then you have the logs present, the PowerShell logs, where you can extract all the commands that were run. But in the end, of course, attackers also try to delete logs, try to circumvent everything and mask as much as possible. So you can also do this with C code. I think even with C# that might be possible. But usually attackers prefer C because of less security boundaries. are there any more questions? And if not, thank you so much for your attention. Don't forget to grab your remaining 8 cookies from behind. And I hope you enjoy the PSConf as much as I do, and see you around.